So now I've put the block along the interface, and we have the angles marked along it. So what we're going to do is we're going to take some pins, we're going to put them in each angular line, and then we're going to use a surveying technique to calculate the angle of refraction. Or I shouldn't say calculate, we're going to use a surveying technique to measure the angle of refraction. So what you'll see now is I've put two pins into the 10-degree line a distance apart, and then I'm going to... So when we're looking through the edge of the block, we can see that the pins obviously don't align, and so what I want to do is shift my angle until they do appear lined up. And once I've done that, I'm then going to take these two other pins and place them so they appear to be in line with the other two. So now they all appear in line, but of course they won't be in actuality. It's a small difference. So let's annotate the diagram. So as you can see, I've marked various different points. So you can see there's 10 and 10, 20 and 20, 30 and 30, 40 and 40, 50 and 50 along the block. I couldn't manage to get 60. I couldn't get the block far enough along for the angle to line up, so couldn't do 60, sorry about that. But what we want to do next is basically we take our 2 points for 10 degrees and we connect them. So I'm just lining that up as carefully as I can, which is not very carefully. There we go. I'm going to do the exact same thing for 20. I'm going to do the exact same thing for 30, 40 as well, and finally 50. If you're following along, you might see there's a slight bit of erasure going on this board. There was a dot on the bit of paper. I accidentally drew the 50 to the wrong mark, so I'm going to get this correct this time. And there we go. So we've marked on these angles here, but that's after it's gone through the block twice, if you think about it. So it's gone into the block, it's been refracted, it's come out again. So that's not quite the angle we want to measure. What we actually want to measure is the internal angle. So I don't want to measure the angle from here, that would be wrong. I want to measure the angle from here inside the block. So I'm just going to zoom in, and you can see I've already marked on the line to 40. So what I want to do is draw on this line here as it goes towards the 40 line. So I'm going to mark that roughly with the ruler so you can see what's going on. And then I'm going to take the camera away just so that I can draw it on correctly. And what you can see now is I've extended this angle out, well this line, I've extended this line out all the way to here just so that when we put our protractor in it'll be easy to measure it. And of course the angle that we want to measure, if these are the angles of incidence, this would be the angle of refraction that we want to measure. So I'm now going to draw in the others and then I'll show you once it's done. In dotted lines, I've marked on all of the angles of refraction that we have to measure. I've written them in ink, and in case that's not clear, I've also underlined. So you'll see the ones I did through the surveying technique are pencil and not underlined. The actual angles of refraction are underlined and in ink. And that should be basically enough to start actually taking measurements. So what we'd do now is we would put the protractor in place precisely as we can, and then we would take measurements off each of the angles off the protractor, I'm going to insert a photo taken overhead, so this is easy to do. But just remember you're measuring the internal angle of refraction, and this starts at 90, so we'll have to be a little careful when we're measuring the actual angle of refraction because of that. Okay, good luck with that.